Tonight, I plan to have a little too much fun with my Samsung 950 SSDs. I've already done the benchmarking and given you a sense of what these little tiny SSDs are capable of in the M.2 form factor. And there you go. They're exceeding the Samsung expected specifications. Now, here's where things get more interesting. What if you have two of them? So I have a second one on loan, and I've put it in the PCI card. And good news, I'm getting the same performance, whether it's the C drive or the D drive in my Windows 10 install. So right in the motherboard, I have one of these, and on the second one is on a PCI card, all in one server. So I'm going to go ahead and use the IPMI feature in this Supermicro Super Server 5028D-TN4T, and I'm going to go ahead and power this up and do some testing that I have not done before. So this should be fun. I plan to abuse or benchmark two drives at the same time. That is very rough on a drive. And here, I'll just give you a clock. There you go. I powered up at 100. And it's rough on a drive, but it's more interesting in that both the M.2 slot and the PCIe slot, they both are 4 lanes. So they both have the same capability, and the benchmarks bear that out. What if you use them both at once? Because what if I have a virtualization environment where I'm using both slots for storage, for instance, and I'm hitting both data stores at once? Well, on the Windows side, where we're going to be, Windows 10 I'm booting to, we can just run the benchmark twice, once on the C and once on the D at the same moment. So we'll be saturating or trying to saturate the PCI 3 by 4-lane bus, and we actually shouldn't come close. Performance will suffer some, but it'll be interesting to see how much it suffers, right? So that's my plan. Now, here comes the clock. Okay, 1 minute in, we got the BIOS coming up. Let me reduce clutter a little bit. When you get a spinning wheel here, that means Windows 10 is starting. Okay, that was an extremely fast boot. A little hard to tell what happened there. I'm going to just continue now. All right. Let me do the setup here. We've got a tiny little iKVM window, right? That doesn't do you a whole lot of good for seeing what's going on. So it'll obviously be a bit better if I go ahead and give you remote desktop. So I'm going to show you remote desktop, give you a nice, pleasant, full window experience looking at this Windows 10 machine. Now, there'll be a few things to note before we get started with the abusive benchmarking. First thing to note, Task Manager, performance. Look at the amount of memory, 128 gig of memory. All right, so physically you have that much. How about Windows key plus R, MS Info 32. Here you can see the BIOS is at 1.0b, and you'll see that 128 gig of memory, and there you have it in the version of a 64-bit Windows. How about the CPU tab? I just saw it spike briefly to above 2 gigahertz, but it's cranked up, so I'm still sort of in benchmarking mode. What does that mean? It means I got the fan cranked, so that if we do heavy I/O for a long time, we want full speed fans so that we don't get any thermal throttling happening. And I've already tested extensively that it does not happen when the fan is cranked to full speed on this particular case with the lid on. All right, now you can see our CPU is at 0, even though I have some basic stuff going on. A USB attached CyberPower PFC LCD. All right, why do I have this going? Well, because it's a very nice UPS, and it has software that can run as a virtual machine appliance to shut down my whole data center. But today, it's just doing Windows monitoring duty, showing that only the server is plugged in with its 2 Samsung 950 SSDs and nothing else, no other drives. And it's not even in the power savings mode, it's more in benchmarking mode, yet we're still sipping only 48 watts. So I wanted to give you some sense of how kind of awesome that is, right? All right. And actually, we could do benchmarking if needed, so I'll have a stopwatch. So I've already done the benchmarks where I didn't have anything running in the background significant. Today, I'm doing sort of the bells and whistles to give you a better sense of the feel of the machine. Yeah, we don't need that clutter. But let me bring up the numbers. So do you remember I said I've done some benchmarking already, and I had this browser window up at the beginning of the video. Let me go back and just leave that reference screen on for ATTO. And that's the tool I'm going to use now. So there, those are the numbers we would expect. So to get started, I'm going to go ahead and just run ATTO on the C drive and confirm that we get similar results to what we got yesterday, even though I'm running a tool that'll look at the watts burned. And that reminds me, I've got another tool called SuperDoctor. Whoa, didn't. Sorry about that. Another tool called SuperDoctor that's going to show us temperatures and all that stuff. Right? So we got all of that going on one screen. All right. So here we go. CPU, you'll see again, running this tiny web service that's looking at the IPMI thermals, numbers, and updating the screen automatically, dynamically every 15 seconds or so. I think it's a polling interval. Will be an awesome thing to run, leaving in the background, and also show you I'll still get good benchmark results. Good being defined by comparable to yesterday's number right there. You'll notice we've gone from 43 watts or so to 64 watts. Now we can't attribute that only to the SSD that can burn up to 7 watts each, because that'd be 14 watts. Well, we're also hurting the CPU a little bit too, but boy, not much, right? Getting 9% CPU. So this is really what I wanted you to see that, yeah, the disk will hit 100% max, especially as we get to the bigger numbers. That's normal. But the CPU with NVMe, the overhead is nice and light, which is good. So looking at the results here, so far looks good to me. Let's confirm that. So bringing up the results I obtained on the same drive and the same system and all that. Yes, the results very much look the same. So that's good. I don't see any significant difference there at all. So I'm not worried about running these less than 1% utilities in the background. And I like that I could see spikes in watts and everything happening, including anything that warmed up a little bit or well, anything. Let's see, what needles are we missing behind here? Nothing important. Dim temperature, all right. So I guess for the next run, I could run it over here, and now we're not blocking anything important at all. All right, and Ethernet is happening because we're doing remote desktop. Again, none of that has an effect. Now, I wanted to run two. That was the point here, right? So I'm going to fire up a second Windows Disk Bench. And if I can think of a place to put it where it doesn't get in the way, I'll go ahead and get that started. I'm going to have to just do something like this. Blocking the second dim temperature. None of the dims have ever been a problem. All right, well, that's the best I can do to avoid blocking you from seeing stuff. So here we go. I need to change that to D and hit start quickly. So they're both at pretty much the same spot, maybe half a second apart. So now we're hitting both at once. The CPU, instead of 9%, is a bit higher, about double, 18%. Now NVMe, remember, I'll show you a little graphic on a different machine's browser. Right there, we've got the reason NVMe overhead is less, because you don't have software latency. You don't have SAS or SATA or anything between you and the storage. It's a whole new interface It avoids SATA commands, for instance. So reducing the latency. Okay, I'll go ahead and speed things up a bit until this test is done, and then we'll talk about it. But you've already seen that you can see disk C and D are staying close to 100% much of the time. Although I don't see both of them 100% for very long, so that's kind of interesting. And the results are, less. Of course they're going to be less. They're both at 100. Both at 100 again. Okay, so now I got a pretty good sense of what 1 versus 2 looks like from a watt burn perspective, from CPU perspective, and from a temperature perspective. So that's it for this video. Really just a head-to-head showing 1 alone and then 2 concurrently. Hopefully you found this video helpful. Thank you for watching and for visiting tinkertry.com.